All right, so this last week we're going to be focusing on annuities and amortizations. An annuity is when you make periodic payments or periodic deposits into an account, or you could be paying something off. A typical thing that looks like an annuity could be something where you are making like a monthly payment, so like a retirement fund, for example, if you want to make a monthly payment of $100 into a fund, and then those payments will earn interest. The thing that's different about an annuity versus a compound interest problem like we were doing before is that the first payment that I make into an account, so say I make monthly payments for a year, the payment that I made in the first month earned interest for 11 months, but the payment I made in the second month only earned interest for 10 months, and the payment we made in the third month earned interest for 9 months. So the earlier you make the payment, the longer it's going to accrue interest. So we can't use the same formula that we were using before, because now we have to account for, when a deposit is made or when a payment is made, and then how that affects the interest. So our formula is going to look a little bit different. If you take a look at our future value formula that we have here, it depends on the compounding period, N, like we had for for compound interest, the annual interest rate, R, the length of time in years, and the periodic payment. Now this is a new variable, R. R represents the periodic payment or the periodic deposit. Typically this is going to be like monthly or semi-annually or annually, and the periodic payment, that time period, should match the compounding period. So the N, if you have a compounding period that's semi-annually, then you can assume that your payments are also semi-annually. Let's see. So let's take a look at an example. We're going to do this example a couple ways. First, we're going to break it down payment by payment. So suppose that we deposit $1,000 at the end of each year into an account which earns 6% interest compounded annually. How much is each deposit worth at the end of 4 years? And then how much is in the account at the end of the 4 years? So we're going to do this sort of the long way first. We will see how much each $1,000 deposit grew individually, and then we can add them up to get the total. Once we've done that, then we'll go ahead and use our new formula that we have, and we should get the same answer. So first, how do we figure out how much each deposit is worth at the end of 4 years? Well, let's make a little bit of a chart, if you will. So let's number our deposits. So deposit number. So that'll be like deposit number 1, number 2, etc. The next thing we need is how many years it earns interest. So years earning interest. One thing that I should clarify with an annuity, you make the deposit at the end of the compounding period. So deposit number 1 occurs at the end of the first year. So that means that it didn't earn any interest for that first year. Okay, so if our time is 4 years total, deposit number 1 happened at the very end of year 1. So it's only going to earn interest for 3 years. Okay, and then let's see, so how much this is worth, so that would be our future value. Future, I can spell, here we go, future value of that $1,000 deposit. Now this $1,000 deposit earns interest, and so it grows according to our standard compound interest formula. So the future value is going to be the principal times 1 plus R over N raised to the NT. And so our future value would be the initial deposit of $1,000 times 1 plus, we have 6%, so 0.06, and we're compounding annually, so we're divided by 1 and raised to the 1 times 3. And so this gives us $1,191.02. Okay, so it's nice. Over the 4 years, well, so the money goes through 3 different compounding periods. It earns interest 3 times. And so we made a little bit over $190 in interest. Now deposit number 2 occurs at the end of the second year. So it didn't earn interest for year 1 or year 2, so that means it's only earning interest for 2 years. And so its formula, if we want to compute the worth of that $1,000 deposit after those 2 years have passed, this is now almost identical, except we're raised to the 2. And so we end up with $1,123.60. Now, deposit number 3 occurs at the end of the 3rd year, so it only earns interest for year 4, and deposit number 4 occurs at the end of the 4th year, so it has not earned any interest. It hasn't been in the account long enough to earn any interest. If we follow the same formula that we have before, adjusting the time as needed, so we have to the 1, and then we have 1,001 plus 0.06 over 1 to the 0. So the last year, our $1,000 is only worth $1,000, and in year 3, our $1,000 at the end of the next year was worth $1,060 even. So you can see that the initial deposit that we made earned more interest, and that's because it was sitting in the account longer, and so it had more opportunities to earn interest. Now the total amount in the account then is going to be the sum of these 4 numbers, and if we add up those 4 numbers, we end up with $4,374.62. Now, this process wasn't so bad for a 4-year account, and especially because it was compounding annually. But what if we were depositing $1,000 every 2 months? So we had 6 compounding periods in 1 year, and then we wanted to do 4 years. That would be a lot to do by hand. So instead, we could use our formula. So let's go back up to the formula. The future value of our account should be $4,374. So let's go ahead and set this up according to the formula. So the first thing we need are the periodic payments, which are $1,000, and then we multiply by, and then let's see the numerator, we get 1 plus little r over n raised to the nt minus 1. So we're going to have 1 plus our interest rate, 0.06 over 1 raised to the 1 times 4, because we are looking at interest after 4 years, and then we subtract 1. This is all in the numerator. And then in the denominator, we have r over n, so 0.06 over 1. That should not be a negative. There we go. And so you want to be careful with your calculator. Try to, you don't want to round anything until you get to the very end. If you do round something at the beginning and then you keep using that and you round at every step along the way, then you can end up with something that's really far off from where it needs to be. Let's see, in this big bracket right here, just so we can see, I end up with 4.374616. And so if we multiply by 1,000, we end up with 4374.62. So $4,374.62, which is exactly what we got when we added it up by hand. The second method, though, is much easier to use if we have, more compounding periods. It's definitely a lot quicker to do. So you don't have to do the first technique unless you're filling out what's called well, we'll talk about that in a minute. So you won't need to do the first part. I just sort of wanted you to see that every deposit is earning interest over a different length of time. And so the deposits at the beginning are going to earn more interest than the deposits at the end. But all of that gets accounted for in our general future value formula.